Hello there. So, what we're going to do is we're going to learn about the laws of motion. And in the laws of motion, there are multiple topics that we'll be talking about. The first one here is known as the contact and non contact forces. Now, the first thing that comes to the mind is what is a force? Any external agent, such as a push, a pull, a punch, a kick, a smash, fine, or a squeeze, anything. Any such agent, any such thing which can change the shape of an object, which can change the size of an object, or which can change the state of rest or motion of an object, can be called as a force. Now, for example, as you can see here, so there is an object here. We have an object here. Now, if I apply some force, it can move. Or if it is already moving and you apply a reverse force, it can stop. Similarly, let us say there's a rubber ball here, and we are squeezing it from all sides. So we can change the shape or we can change the size of this object. So these all are examples of forces. Now, the next thing that we are going to do is we're going to try and understand what exactly are the various types of forces. Now, basically, there are two types of forces. We can have contact forces and we can have non-contact forces. What exactly is a contact force and a non-contact force? Let us see. Let us take an example. There is an object here. For example, if you want to move any desk or any table in your home, what will you have to do? You will actually have to be, let us say this is you, fine, and you'll have to be pushing it, fine. When you push it, you can then move the object. Now, did you or did you not actually touch the object? You did. It's an example of contact force. Similarly, let us say that there is an object kept here and you're applying force. You must have learned about friction, isn't it? So when two objects are in contact with each other and they try to slide over one another, there is a force of friction here. Fine. Again, this is a contact force. So when you are applying a force in such a way that you actually have to be in contact with the object, we call it a contact force. Similarly, what are non-contact forces? Electricity or electrical forces are non-contact. Magnetic forces are non-contact forces. Gravitational force is a non-contact force. Now, electrical forces. If you have a plus charged object and let us say a minus charged object, then they can move away. They can move towards each other. You must have done the experiment. If you take a plastic comb, you rub it on your dry hair, and you bring it near extremely small pieces of papers, then what happens? The papers will move towards the comb. Why? Because of electrostatic forces or electrical forces. So electrical forces can be attractive, it can be repulsive. Similarly, if you have, let us say, a magnet, a bar magnet, fine, and you have a piece of this. So this is a bar magnet, and you have a piece of iron here. If you bring the magnet near the iron will rush towards the magnet. Now, to bring the iron in contact with the magnet, you actually don't have to touch the magnet with the iron. The iron will rush by itself. Why? Because there is a non-contact force working here, the magnetic force. Similarly, if you drop anything, fine, if you drop anything or you throw anything, fine, what happens? It always tends to move in the downward direction towards the earth. Why? Because of earth's gravitation. The gravitation force is a non-contact force. It is attracting the object towards it. So when you have forces in which the objects have to be in contact with each other, then we are talking about contact forces. And otherwise, we are talking about non-contact forces. Now, we'll be dealing with some more types of contact forces. Okay, and here they are. So let us say the frictional force. Now a frictional force happens when we have two objects or two surfaces in contact with each other. So here is surface number 1 and here is surface number 2, and let's show them in contact. So here is the contact between them. So if you apply an external force on this object, there will be a frictional force in the opposite direction. Now this frictional force happens because of the contact between the two surfaces. The two surfaces are in contact and hence they tend to bind themselves. The surfaces tend to bind themselves. So you have to apply some force to move them. Okay. So that is an example for you. Okay. So frictional forces are basically contact forces. Similarly, we can have another type of a contact force. We call it a tension force or simply calling it tension. Let us say that there is, a hook attached to the ceiling and there is a wire, and on that wire we have a bob here. Fine, it's got some so this is a bob and it's got some weight, let us say 10 kilogram. Fine, if there is a 10 kilogram weight, it will be acting in the downward direction. So this string here, this string will try to keep, you know on keep this particular bob from moving downwards. So it will have to keep it there. So there will be a force acting here. This force is called a tension force. So when a force is acting through a one-dimensional structure, like a string, a chain, a rod, a very thin rod, a wire, a rope, fine, we call it the tensional force or a tension. So tension is another kind of a force. Fine, this is again, as I stated, it is a um, contact force. Similarly, we can have forces like action and reaction or normal reaction. So we can have a normal reaction force also. Now what happens in normal reaction? Again, let us say there is a table and there is an object kept here. Now if there is a weight of this object here, so what will happen? This particular, the lower surface, it will try to balance the object so that it should not break through. So then it will apply a force which will be equal to the applied force here. This is called the normal reaction force. It can be denoted by N, it can be denoted by R, fine. So this is called a normal reaction force. Again, this is a contact force. So the contact forces can be of various types. Similarly, we have already discussed about the non-contact forces, fine. Now let us talk about the certain properties of non-contact forces. Okay, so some properties of non-contact forces. So what are some properties? The first major property that we are talking about is that they do not require a material medium. Fine. So no material medium is required. So you don't require a material medium. Electrical forces, magnetic forces, they can work in vacuum. Gravitational force, it can work in vacuum. So you don't really require a material medium. The second thing, they can be both attractive or repulsive. Now we know that gravitational forces are all attractive forces. Electrical forces can be both attractive and repulsive. Magnetic force can be attractive as well as repulsive. So there are different types of forces that can these are different properties of the forces. So they can be attractive, they can be repulsive. Similarly, what exactly can these forces do? They can set an object in motion. Fine. So what can these forces do? So effect of these forces. And when I say these, I'm not just talking about non-contact forces. I'm talking about all types of forces. So effect of these forces, it can, you know, set off any object in motion. So if you have something like, for example, this pen, if I have this pen, I want to set it off in motion. All I need to do is I need to throw it, and it will be in motion. A straightforward example. Or it can stop a moving object. So a moving object can be stopped. So let us say something is coming towards you. Let us say you're playing cricket or football, and the ball is coming towards you. What can you do? You can catch hold of it. A force. You just stop the ball from moving. So it can stop a moving object. And then it can change the shape of an object. Again, another example that you can find at your daily, in your home. When you take atta, fine, wheat flour, and when you make a dough, the dough is soft, fine. You can squeeze it, you can pull it, you can twist it, you can convert it into different kind of shapes. So you can change the shape by the application of the forces. That is another thing you can do, or the forces can be done. Similarly, there are other things. It can change the size of the object. Again, similarly, as I said, the dough, fine, you can just crush it, it will become small. You take a lemon and you squeeze it, the shape, the size, they both change. So you can change the shape of an object, you can change the size of an object, you can stop an object from moving, you can set an object into motion. So there are a lot of things that the forces can do. So finally, what have we all learned today? We have learned about a couple of things. Number one, what are forces? Fine. Any external agent that, for example, push and pull and etc., which can change the shape, size, or state of motion of an object can be called a force. Similarly, we learned about types of forces, contact and non-contact forces. Contact forces are where two objects need to be in physical contact for a force to work through. Frictional force is an example, tension is an example, normal reaction is an example. Non-contact forces are also there. They do not require a material medium. Electrical force, magnetic force, gravitational force, these are all examples. Fine. So I hope you have understood the difference between contact and non-contact forces. Fine. Now